Hello everybody and welcome to chapter 6.2 of exponential and logarithmic functions. Again, we are continuing with our studies of advanced functions, and day by day we're getting closer and closer to finishing the course. So today we're going to finally learn what a logarithm is. So we're going to discuss what a logarithm actually is, and then we're going to learn how to evaluate them. So what is a logarithm? Well, the logarithmic function is the inverse of the exponential function. So everything we've done in chapter 6.1 with the inverse of the exponential function was actually everything we need to do to understand what the logarithmic function is. So the value of log b of x is equals to the exponent to which the base b is raised to produce x. The way you would read this is the value of log of x to the base of b is equal to the exponent to which the base b is raised to produce x. So again, to read this, you would say that we have a logarithm of our x value to the base of our b value. So we can actually write an exponential equation as a logarithmic expression and vice versa. So from here we see that y is equals to b to the power of x. So we can actually write that x is equals to log of y to the base of b. Then when we see y is equals to log of x to the base b, we can actually write that as x is equals to b to the power of y. Again, this was what we used to define the inverse of our base function or our exponential function. Again, exponential and logarithmic functions are only defined for positive values of the base that are not equal to 1. So for when we have y is equals to b to the power of x, b has to be greater than 0, x has to be greater than 0, and b cannot equal to 1. The reason why b cannot equal to 1 is because if it were equal to 1, then we would have infinitely many 1s for any value of x. And that is not what we are looking for. At the same time, we have our y is equals to log of x of base b, where b is greater than 0, y is greater than 0, and b cannot equal to 1. Here, it's really important to understand that the logarithm of x to the base of 1 is only valid when x is equals to 1, in which case y has an infinite number of solutions which cannot be a function. That is literally what a function cannot be. It has to have one specific y point for every x point. Also, we have some common logarithms, which are logarithms with a base of 10. When you have a logarithm of base 10, you don't have to write the base. So log x is the same as log of x of base 10. Now let's talk about evaluating logarithms. To evaluate logarithms, you must simply raise the base to the exponent of y to get the x value. That might sound a little complicated, so we are going to do a few examples. So the first one is y is equals to log of 256 of base 4. To solve this, we must find out to what power must be raised 4 to get 256. I don't know why it's written like that, sorry about that. Essentially, all we know is that 256 is 4 to the power of 4. Since 4 to the power of 4 has our exponent as 4, our answer is 4. So again, we're just going to look for this top value over here in our solutions. So let's talk about this example now. Y is equals to log of 1 over 32 to the base of 2. Again, we must find out to what power must we raise 2 to get 1 over 32. Again, we're dealing with a value that is less than 1, which would mean that we're dealing with negative exponents. We know that 2 to the power 5 is equals to 32. So then we also know that 2 to the power of negative 5 would be 1 over 2 over 5, which is 1 over 2. So we got our value. Since we got our exponent to equal to negative 5, our answer is negative 5. Now, you must also learn how to approximate logarithms, because not every value you're going to work with will be a perfect exponent. So what do I mean by that? For example, let's look at this question here, which I need to fix. Somebody didn't write the right number. Okay, there you go. We're finding out log of 62 to the base of 3. We know that you can't raise 3 to any whole number to get 62. So we have to approximate. This will be a little bit of a guess and check, but for example, we know that 3 to the power of 3 is 27, which is too low, but 3 to the power of 4, which is our next whole number, is 81, which is too high. So now we know that our value for y has to be between 3 and 4. From here, we can start using averages to find out closer and closer values. So if we're going from between 3 and 4, I choose something in the middle, which would be 3.5. So 3 to the power of 3.5 in your calculator is approximately 46.7, which is too low. Now I would go in the middle from 3.5 to 4, which is 3.75. This is getting us 61.5, which is really, really close. So let's see if our next value will get us any closer. Our next value is 3.76, which got us 62.2, which is now overshooting the value. Just for a little check, we did 3.77, which is even higher. So our answer would be around 3.76. No one's stopping you from going even further. So for example, between 3.75 and 3.76 to figure out the really, really close approximations. But this is around how much you'll need to know. With that being said, there's a lot of homework for today, but do not worry because a lot of it is genuinely mental math. So let's look at the questions that I've assigned. I've assigned 1, 2, 3, 4. So for 1, 2, 3, 4, it's asking us to write each equation in logarithmic form. So again, to do that, we figure out our base. This is gonna be our the number after a log, and this will be our answer. So what we're getting is log of 64 of base 4 is equals to 3. You could do that for all of them. Again, it's really simple. You're just using what we've learned on the previous slides. So this information here. For 2, it's asking us to evaluate a logarithm. So again, you could do the procedures we learned about. What value must I put to what value must I raise 2 to get 64? Well, again, we know that 2 to the power of 5 is 32, so this has to be to the power of 6. Therefore, our answer is 6. Again, you could do that for all of the questions here. This one might seem a little bit complicated, but do not worry. You could simply evaluate what this value is. Or you could understand that this is the same as 6 to the power of 2. And then we know that when we have a power to the power, it's the same as multiplying them. So you could get your answer that way. For 3, it's this asking us to evaluate this common logarithm, which would mean base 10. So this is really, really easy. Lastly, for 4, it's asking us to write it in exponential form, So again, now you're just turning this into exponents. Something we've learned is super simple. Next, we have 9, 11, and 14. So 9 is making you graph the function, and then it's inverse. So you're gonna see the understanding of log of x, which we know is a logarithm of base 10, and then its inverse should be the exponential form for 10. So y is equals to 10 to the power of x, or to the power of y. Again, nothing difficult, just simple sketching. 11 is making us make a prediction about what this would mean for any value of when x is greater than 0 and x cannot equal to 1 for reasons we have learned before. Again, this shouldn't be really hard because all this means is we're raising something to the power of something to get the same value. To get the same value, we should probably raise it to the power of 1. So this should always evaluate to 1. We could also graph this function to prove that. Over here, I've graphed the function. You could see that it's not defined for 0, and it's not defined for 1, which is what our restrictions stated. But for everything else, our value is 1, as you can see here. Also, it's asking you to conclude about the value of log of x to the base of x. Again, all you conclude is that it always equals to 1 except for our restrictions. Lastly, I've assigned 14. Sorry, it should be over here. There you go, 14. For 14, it's asking us to solve a word problem. However, this should be pretty simple. We're gonna substitute 50 in and then solve for our d value. So we're gonna put 50 in here, divide by 125, take the log of that. So 50 divided by 125 is 0.4, so log of 0.4. You'll understand how to put that into your calculator. Then you multiply by that and get your answer. Then it's asking you what will happen if the intensity doubles. Does this mean the car is half as far away? Well, you could test that out and understand whether or not it is true. And then it's asking you about the implications of these results. So again, this is just testing whether or not you understand what is being spoken about. If you did everything correctly, for A, you should get around 66.5 meters. For B, you should get around 16.2 meters away, which is way closer than half. So that is great. Now that we know this, that would mean we're getting into a more dangerous situation. So the implication of this would mean that you have to drive slower. If you see that something is coming at a really rapid speed towards you and you could see the light doubling, that means it's way closer than half. So you should be careful. Again, this is just trying to understand what this meant. Nothing too difficult. But if you have any questions, feel free to contact me about it. With that being said, as you can see, today's lesson was super short. But that is because we already done most of the work with logarithms, just not knowing what they were actually called. All the other questions in the textbooks are still testing your understanding of substituting in values and how to evaluate logarithmic functions. So if you do more questions, it will definitely help you out. With that being said, I hope you've learned a lot, or maybe a little bit more than you thought you would, about logarithms. Tomorrow we'll be talking about 6.3, which is transformations. Again, I'll guide you all the way through that, so do not worry. I hope to see you next time. Bye bye!